We all know there are 24 hours in a day. It's a fundamental fact about our planet, shaping our lives, our societies, even our biology. But what if I told you that this wasn't always the case? And more importantly, what if I told you that it wouldn't stay this way forever? That's right, folks. We're talking about deep time here. A cosmic perspective on something as seemingly mundane as the length of a day. It turns out that Earth's rotation is slowing down, and while it's happening at a glacial pace, it's an inexorable march towards a future where a day is 25 hours long. So, buckle up as we explore the fascinating science behind this temporal shift and delve into the profound implications it holds for life on Earth. From our sleep cycles to our energy grids, our agriculture, and even the delicate balance of our ecosystems. This isn't just about an extra hour in the day, it's about understanding our place in the grand, cosmic dance and preparing for a future that's quite literally going to be longer than we're used to. Let's start with the culprit, or should I say the ex-culprit, in this cosmic affair, the Moon. You see, billions of years ago, when Earth was still a hot mess, literally, the Moon was much closer, like uncomfortably close. And when something that massive hangs around that close, it has a gravitational grip, a tug that affects not just the tides, but the very spin of our planet. This gravitational dance between Earth and the Moon is what we call tidal forces. These forces cause friction, a cosmic brake pad, if you will, that very, very slowly slows down Earth's rotation. Now, this slowdown is incredibly minute. We're talking milliseconds over centuries, but over millions and billions of years it adds up. And as Earth's rotation slows, the Moon, in a sort of celestial payback, drifts further away about 1.5 inches every year. So how do these tidal forces actually work? Well, it's all about gravity, but not just the what goes up must come down kind of gravity. The Moon's gravity pulls most strongly on the side of Earth facing it, creating a bulge of water. A similar bulge forms on the opposite side due to inertia. These bulges are what we experience as high tides. As Earth rotates, these bulges, influenced by the Moon's pull, don't line up perfectly with the axis of Earth's rotation. This misalignment creates a sort of gravitational tug that acts like a brake, slowing down Earth's spin over time. Now you might be thinking, an extra hour, that's great! More time to binge watch my favorite shows. But it's not that simple, folks. Our bodies are incredibly complex machines, fine-tuned over millennia to the rhythm of a 24-hour day. This internal clock, known as our circadian rhythm, regulates everything from sleep-wake cycles and hormone production to body temperature and even cognitive functions. It's deeply intertwined with the cycle of day and night. A shift to a 25-hour day, even a gradual one, throws a wrench into this finely tuned system. We're talking potential disruptions to sleep patterns, hormonal imbalances, and even long-term health consequences. And that's just us humans. Imagine the ripple effects throughout the entire web of life on Earth. Chapter 4, Work and Leisure. Think about the societal implications. Our work schedules, our transportation systems, our entire way of life is structured around a 24-hour day. A 25-hour day means rethinking everything. Will we work longer hours? Will we have longer weekends? How will this impact productivity, creativity, and our overall quality of life? These are questions we'll need to grapple with as we adjust to a new temporal reality. And let's not forget about international relations. Time zones are already a headache. Imagine trying to coordinate global commerce and communication with an extra hour thrown into the mix. Chapter 5, Energy Consumption. Our energy consumption patterns are also deeply intertwined with the cycle of day and night. We use more energy during daylight hours for work, transportation, and other activities. A longer day means more daylight, which could lead to increased energy demands, particularly for cooling in warmer climates. This could have significant implications for our energy grids, renewable energy production, and efforts to mitigate climate change. We might need to rethink our energy infrastructure, invest in more efficient technologies, and perhaps even adjust our daily routines to conserve energy. Agriculture, the very foundation of our civilization, is also deeply connected to the rhythms of nature. A 25-hour day means a longer growing season in some parts of the world, which could be a boon for food production, but it also means Farmers will need to adapt their planting and harvesting schedules, irrigation systems and livestock management practices to align with the new day length. This will require innovation, flexibility and a deep understanding of how plants and animals respond to changes in daylight. And let's not forget about the potential impact on pests and diseases. A change in the length of the day could affect their life cycles as well, leading to new challenges for farmers and potentially impacting global food security. Our technological infrastructure is also deeply reliant on precise timekeeping: satellites, telecommunications networks, financial systems, even GPS navigation. They all depend on atomic clocks and synchronized timekeeping. A 25-hour day would require a fundamental recalibration of these systems, a technological feat that would be both complex and costly. But it's not just about updating our technology, it's also about rethinking how we conduct scientific research, how we measure astronomical events, and how we understand the very fabric of space-time. The natural world is a symphony of interconnected rhythms, and a change in the length of the day could disrupt this delicate balance. Animals rely on daylight cues for feeding, mating, and migration. A longer day could alter these patterns, potentially leading to mismatches in predator-prey relationships, changes in breeding seasons, and disruptions to migratory routes. This could have cascading effects throughout entire ecosystems, impacting biodiversity, food webs, and the overall health of our planet. As we look ahead to a potentially longer day, we must consider the implications and start preparing for the changes that come with it. From adjusting our daily routines to rethinking our technological infrastructure, we'll need to adapt to a new temporal reality. The transition to a 25-hour day will occur gradually, but the impacts on human life will be profound and far-reaching. Buckle up for a future that's full of possibilities and challenges. The shift to a 25-hour day will require a fundamental rethink of our timekeeping systems. From atomic clocks to digital timekeeping, we'll need to adapt our technologies to accommodate the new day length.